So this one's example 38 from page 195. Simplify, giving answers in simplest rational form. All right, so remember, anything to the 0 power, 1. And we are done with that problem. Okay, except for, again, the only case that doesn't work is if it's 0 to the 0 power. Okay, 3 to the negative second. Basically, the only thing we can do with that is turn that into 1 over 3 to the second, right? So remember, whenever you get a negative exponent, move it to the bottom. Okay, or we can rewrite this as 1/9. That looks a little bit nicer. Okay, but again, I think that would be probably just fine. This just is a little bit better. All right, 3 to the 0, anything to the 0 is 1, minus, and then 3 to the negative first is 1 over 3 to the first. So that's 1 minus a third, right? Because we don't really even need that to the first power. So let's just get rid of that. 1 minus a third is really what they're talking about. We want to get the same denominators here to subtract fractions. So that's 3/3 minus 1/3, right? Because 1 is the same as 3/3. So 3/3 minus 1/3 is 2/3. And then this one here, 5/3 to the negative second. A couple different ways to do this. Probably the easiest is just to distribute that -2 to both of those. So we get 5 to the 1 times -2 is -2 over 3 to the 1 times -2 is -2. And then since this is a negative exponent, move that one down. And since this is a negative exponent, you move this one up. So it just turns into, let's put our little separating line so we know what we've gone to the next step. So that 5 to the negative second comes down, turns into 5 squared. And the 3 to the negative second comes up, so that turns into 3 squared. Okay? Again, this would be just fine, or again, you could write that as 9 over 25. A lot of people like the way that that looks better, so that would probably be your better answer, but for what we're doing, that would suffice.
Please report to the main office. Tomorrow.
Okay, 3 sets of examples left. We're almost there. Oh wait, did I lie? So 3, there are, yes, 3 sets of examples left. Example 39, page 196. Write the following without brackets or negative exponents. So you got to write all these with positive exponents. So that's 5 to the first, x to the first. So really that's 5 to the negative, oops, can't read that. 1 times -1 is -1. And then 1 times -1 is -1. So that's 5 to the negative first, x to the negative first, without negative exponents. So we got to turn that into 1 over 5 times 1 over x, or the nicest way to write that is just 1 over 5x. Okay? A simpler way to do that would really just be to have gone, you can really go straight from this step to that there, because if you think about it, it's 5x to the negative first, so that's just 1 over 5x. So you can do it either way. If you can do that shortcut way, then go for it. Okay. Now, again, here's where it comes in handy to actually write your ones wherever there's not an exponent, because this is 5 to the positive first, and that's x to the negative first. So that 5 is going to stay in the numerator, it's going to stay up top, and then the x to the negative first is going to go down to the bottom. Okay, and again, you don't need to write that 1 there, so let's just take that back off, and we just have 5 over x for this one. Okay, this one here, 3 to the first, and then b to the second, all to the negative second power. So distribute that -2 to both of those, and that's 3 to the negative second, b to the negative fourth. And again, since those are both negative, I'm going to move those to the denominator. So that is 1 over 3 squared b to the fourth. And that would be just fine like that. Or you could write it as 1 over 9b to the fourth. Either way. Alright. Next to last set of examples, example 40 from page 196. Write the following as powers of 2, 3, and or 5. So 8, hopefully you realize, is 2 to the third power. So we can just write that as 1 over 2 to the third, right? Or what they didn't specify well enough, but what they really are looking for to turn this into is move this back up to the top and then switch that positive exponent to a negative exponent. So this is really 2 to the negative third is what we're looking for on that. Okay. 9 is the same thing as 3 squared, so we'll turn this into 1 over 3 squared to the n. So that's 1 over 3 to the 2n. And again, we move that to the top and turn this positive 2n to negative 2n. So that's 3 to the negative 2n power. Okay? And then on this one here, 25 is just 5 squared. So we write 5 squared over 5 to the 4th. Right? So we do 5 to the 2 minus 4 gives us 5 to the negative 2nd, and then we're done. Okay? Last set of examples. You're almost there. Okay. Last set. Example 41 from page 197. Write in non-fractional form, so you got to get rid of the fractions. Okay? So that's 3 to the first, x to the first, all of these here. I'm just going to write ones with all those that don't have them. Okay? So here's what you can do on this. This is the way I've found to be the easiest. I'm going to rewrite this as x squared over x to the first plus 3x to the first over x to the first plus 2 over x to the first. And now I'm going to simplify each one of these. So x squared over x to the first is just 2 minus 1, or just 1. So that's x. These here, the x's are just going to cancel out, right? So you just get plus 3. Okay? And then we get plus 2 over x. Okay? Now, and that's x to the first. And it says to write it in non-fractional form. So this x to the first has got to come back up there. So that's just going to be x plus 3 plus 2, and then that x to the positive first on the bottom comes up the top and turns into x to the negative first. So there's our answer. X plus 3 plus 2x to the negative first. Okay? And then last one, same thing, x cubed over x squared plus 5x to the first over x squared minus 3 over x squared. 3 minus 2 gives us 1. 1 minus 2 gives us negative 1. And then another way to look at this is x to the 0. 0 minus 2, a little bit of a shortcut would be to go 0 minus 2 is 3x to the negative 2nd. And then you don't have to move it to the bottom and then move it back to the top. Alright? And that is our final answer for that one. Okay, we're all done. Finally. So you've learned, and you should be able to apply all the index laws. And again, there are 7 of those, with both constants and with variables. And then you're actually also combining those index and power laws together. Okay? So if you have any questions, feel free to ask. Thanks.